Okay, so hi guys. Again, I'm back with the electrochemistry last minute revision session. The exam is tomorrow, I guess, right? So I think most of you might be pretty much busy. So I have made sure to keep the revision, last minute revision session as short as possible. Okay. Now, electrochemistry, there are again a lot of parts. First is related to the Faraday's law, first and the second law. Numericals are very simple. Please don't miss that. Then the next is cell representation and the reactions. They are again not difficult at all. And then the other section is about these other types of cells: standard hydrogen electrode, calomel electrode, right? Lead acid battery. And the final part is basically the corrosion, right? Now most of you just ignore this section on corrosion, thinking that it's just a very small part, but actually, they could ask one short note based on corrosion itself. So please do not miss that topic. It's very simple if you are able to understand, right? Iron converts to Fe2 plus, Fe2 plus gets converted to Fe3 plus. Now this entire surface acts like a mini electrochemical cell and the reaction keeps on happening. So it's given very nicely in the textbook, as well as you could just even have a look at different videos. But again, my objective is just to make sure that you don't miss any of the important parts in this particular topic. Again, physical chemistry, so numericals are a must. In this last moment, if you are not able to do the unsolved one, at least try solving the solved ones thoroughly and understand the concept so that you are able to understand each and every part of the topic, as well as you are able to do any of the unsolved questions, any new question that appears in your book. Okay, now just make sure that you have the necessary things with you, the necessary values with you when you are doing all the reactions. You can use shortcuts if you want, but anyway, theory exam it's going to be, so you'll be having a lot of time for that. Okay, now let's begin without wasting much of time. Okay, so here is the first formula list. Ohm's law, most of you are knowing about it. Then you have specific resistance, rho equal to Ra upon L. Conductance is reciprocal of resistance, right? And then you have specific conductivity kappa, which is 1 upon rho. Cell constant value is L upon A, right? And the values are pretty much understood. Okay, most of these formulas you have already used in the entrance exam solving, so I think it should not be a problem for you. Okay, so let me move ahead. Yes, Faraday's first law of electrolysis: amount of a substance deposited or liberated at any electrode is directly proportional to the charge, right? And Q is equal to IT, so you have M equal to ZIT, and then Z is equal to atomic mass upon N into Faraday. Second law, M1 upon M2 equal to E1 upon E2, right? This you have already done in class 11th as well, correct? So simple numericals you could solve. And then molar conductance 1000 kappa upon C, equivalent conductance 1000 kappa upon C, right? And then you have a molar lambda m equal to lambda n into n factor. I think these things are for your entrance exam. For weak electrolyte and strong electrolyte, what exactly happens, right? I think most of you should solve the problems related to molar and equivalent conductance over here, right? So just make a note of these formulas. Try to solve at least one question from the solved as well as unsolved. Infinite dilution law, that is Kohlrausch law, right? AXBY is XA. AXBY is basically XAY plus YBX minus, and then how are you going to write the equivalent conductance and so on. So the degree of dissociation formula is already given to you, right? But I think not much of difficult questions have been asked so far, so you can just go by the simple problems if you want, right? But anyway, it's your call. It is always better to prepare something advanced, right? So that you are in a better position than the other candidates, correct? And then you have the solubility, and then you have the electrochemical cell representation: metal in contact with the metal ion, then double slash Cu2 plus. So you have anode, you have cathode, anodic oxidation and cathodic reduction. How to represent the half cell, how to calculate the cell potential, which is right hand EMF minus the left hand EMF, or cathodic reduction minus anodic reduction, right? So just make sure that whatever values you are being given, you are actually checking it, whether it is oxidation potential or the reduction potential, reversing the sign if it is necessary, and then doing this topic. Then you have the standard free energy calculations. delta G equal to NF E naught of the cell, and the representation, the formulas. Okay, so I'm not going to discuss too much about it. The formula list is pretty much clear. You can use as much as possible. At equilibrium, delta G equal to 0. This is something that is going to have a lot of problems and numerical problems assigned to this. So it's better you can prepare how much ever it is possible from your side. Now do not miss these different types of cells: standard hydrogen electrode, then you have calomel electrode, then the lead acid battery, then you have cell representation, calculation of EMF using Nernst equation, and the most important, please do not keep this in option. Corrosion and its protection should not be kept in option under any cases, because it's not worth. It's very simple. Okay, so this was about the things that you're supposed to do for electrochemistry. Now, again, a piece of advice that I would like to give you. Remember that physical chemistry tests, so units are mandatory. I don't want you to lose marks because just you forgot to mention the units or just you have written wrong units. Okay, solve all the end of the textbook questions, including numerical. I would specify more of numerical because I do agree you have a lot of other topics to study, so you may not be able to solve each and every question. Okay, so I wish all of you a very good luck, and just stay calm and do the studies very well and rock an exam. Okay, thank you.